Today I'm really happy to show you the Lidar HD of National Square High Resolution 3D Elevation Dataset produced by IGN, the French National Mapping Agency. This program aims to deliver a homogeneous, precise and comprehensive description of both terrain and above-ground features like vegetations, buildings, bridges across metropolitan France and the French overseas territories. So it was launched in 2021 and it's expected to be completed by 2025 or max 2026. This dataset is truly outstanding. The average point density is at least 10 points per square meter and about 5 points per square meter above 3,200 meters altitude. That ensures remarkable coverage and detail. So the models are available as a geotype grids at 50 cm resolution. They are till in 1 kilometer per 1 kilometers. Plus raw LAZ point clouds of up to 500 megabytes up to 2 gigabytes per tile. So because the data are open and freely available under the EthaLab Open License 2.0, it's possible to download, visualize and use this data for GIS, 3D modeling, for environmental analysis, forest management, risk assessments, urban planning and many other applications. So in this first tutorial we'll see how to access, download and start processing these Lidar HD tiles for your own GIS project. So of course the first step is to create an account. So basically you will have to click on login. Here you will have to create an account. So you can enter your email address here or to set up pseudo and you will validate and continue setting up. After that you can go to the catalog and here you will see the HD Lidar, a 3D map of the ground and surface of France. You can click on it and you will see this window. You scroll a little bit and here you can view the map in full screen to see the tiles that you want to download. So you see here that the entire coverage is still not ready, but many tiles are available. So for this tutorial, here you see that we can download more precise tiles. So here you have the point clouds. We will begin with those files. So you can download the list of links here. So you can copy and paste in a new folder this list of links. So you can see these lists. So with this code executed in the Windows PowerShell, you will see that the HTTP request is transferring here. So it may take a while because there are hundreds of megabytes. Up to gigabytes. We see it's currently transferring those point clouds. We see that a new folder have been created, COPC files, and yes, the COPC LAZ points are currently transferring here. You will have to download Anaconda or the Mini Conda. So here you have all the links, so you may have to sign in before. So after that you will be able to open the Anaconda prompt. So you double click on it. This new window will open. And here you will be able to create a new environment. So I called it Lidar Env. But you can name it whatever you want. And within this new environment you will have the PDAL and the GDAL module, so this will allow you to convert all of your COPC.LAZ points in a geotiff. So you will see all of the libraries will be imported. So don't worry, it can take a while. But after that you will have your new environment deployed. After that you will have to activate your environment. So basically you just have to write this. So now we are going to see how to create the batch file that will convert all of those COPC.LAZ points files into a geotype. So let's see together how to create the convert batch file. So basically this batch file will convert all of the tiles of the COPC files that you have here. So I create a new folder called geotype, and basically it will be here that all of the point clouds will be converted into a TIFF. So you need a batch file to do this. So basically you will have to open for example a text file here, and to save it as a batch file, so you will have to go into the same folder, into the same environment. So here you will have to select batch file here, and you name it convert. So I won't do it again because I already did it. So here let's see how it works. The echo off turns off the command echoing in the console to make the output cleaner. Here we enable delayed variable expansion, so it allows us to use var to get updated variable values inside loops. Here of course we set variables for the source folder containing the COPC.LAZ files, and the output folder where all of the TIFF files will be saved. So here it creates a version of the output path where all the backslash are replaced by forward slashes, because it can make some error. So this allows us to handle this error. After that you create the output directory, and here hide the errors if the folder already exists. So we have the loops over every COPC LAZ file in the source folder. So the echo conversion of will print the name of the current file that is being converting. So here it converts and stores the full file path in file path after converting all backslashes to forward slashes for JSON compatibility. Here you set the base name that extracts the file name without extension to the base name, so you will find the name of the IGN Lidar files. So after that you will be able to generate a temporary JSON file describing the PDAL pipeline to convert the LiDAR files. So it specifies the input LiDAR file, the GDAL writer outputting GeoTIFF when the given parameters, so for example resolution, interpolation type, the data types, and so on. So it displays the generated JSON content into the console. So it's useful for debugging, especially with those heavy files. So here it runs PDAL with the generated pipeline to perform the actual conversion for the COPC.LAZ to .TIFF. In here you end the loop over files, and after that we delete the temporary JSON file after all conversions are done. So you can save this file. So after this you will have to call your batch file that will apply the conversion of the COPC.LAZ points files. So you will just have to call this batch file, and PDAL is trying to read the COPC.LAZ and correctly writing the TIFF file. The 4 tiles we have. So after a while you will see that it will just step over to convert a second file. So basically it can take up to 20 minutes. Of course you can check. Okay, you see that you have your .TIFF file. So it managed to do this. You will have to wait until all of the tiles have been well converted. So let's open together QGIS and see the first few examples, the 2 tiles that have been converted here. So in QGIS I can select it and drop it into my GIS project. Okay, great. So here I kept the canopy on purpose because it gives many informations about the forest and vegetation, which could be interesting for ecological study, for example. But if you need to see how to subtract this canopy, you will have to change your batch file and to write some few other steps in your pipeline to subtract the canopy. So that's it for this tutorial. Now you've seen how to convert your COPC LiDAR files into high-resolution raster layers, and you will be able to explore the canopy structure over the forests of Chambord. In the next video, we'll go beyond visualization. I'll show you how to extract canopy heights model, detect gaps in the forest cover, and even model forest dynamics using real data. Thank you for watching. Don't forget to subscribe and see you in the next one.